Good morning, everybody. Today, we're going to look at the next learning target. I can solve linear, literal, and absolute value equations. So this should be review from a previous class. So the first thing we're going to do, and I believe I'm doing probably mostly all the odds, but so this here is a linear equation. So hopefully you see you have distribution. So you got 39 minus 5k equals 1. And then this guy right here, that's positive 64, and then positive 8k. So we combine our like terms. You get 39 minus 5k equals 65 plus 8k. So there's lots of different ways to do this. What I do is I always bring the smaller to the larger variable. So I'm going to add 5k to both sides. So I get 39 equals 65. And what is 8 plus 5? What's 8 plus 5? Is that 15? So, or 8 plus 5 is 13, so that's 13k. And it's a two-step equation, so I subtract 65, I subtract 65, and what is that? Negative 34 equals 13k, and then I divide both sides by 13, and I believe that's right? 39 minus 65 is negative 26. Can't think today. Divide by 13, divide by 13, k is negative 2, right? That's an easy one. Let's look at another one. This one, same thing, you have distribution. So distribute this. This is 36 over 3w minus 204 over 3 equals 7w minus 68 plus 5w. So 36 over 3 reduces to 12, so that's 12w. And what's 204? Does 3 go into it? So that's 12w minus 68 equals 15w minus, not 15w, 12w minus 68. So 12w minus 68. Okay, you should notice something's going on, but if I subtract this right here, subtract 12w, I get negative 68 equals negative 68. This is identity. This means that you have infinite solutions, okay? This means you have infinite solutions. So anything you plug in will work, okay? So this has lots and lots of solutions in it. Hopefully that makes sense. So what if, just kind of going off the cuff, if I got something like, if we would have the problem, it would have been something like 12w plus 8 equals 12w minus 7. Well, then you get 8 equals negative 7. That one is no solution, okay? That's no solution. And hopefully you've seen that before, okay? I hope you've seen that before. So the next thing we're going to talk about is literal equations. So literal equations are kind of neat. Literal equations are kind of neat. So literal equations, you basically just treat each thing as if, like each letter as if it's separate, so it's a variable. So this one, I want to solve this for the letter J. If I want to solve this for the letter J, right? I'm going to treat everything as like, so what I try to tell people is, okay, so I want to get J by itself. So the first thing I'm going to do is I'm going to times both sides by 3J. Times this by 3J. So now that goes away. I get 8H equals 18KJ. So I got to get J by itself. So what's happening to J? It's being multiplied by 18K. So I'm going to divide both sides by 18K. So then this, you get 8 over 18, which you can reduce 8 over 18. 8 over 18 is 4 9, so this is 4h over 9k equals j. So it's like solving for a letter of the alphabet, okay? Sometimes you've probably seen something like this one. This is the area formula. This is the area formula for a trapezoid. So I want to solve this for b sub 1. So what's happening to b sub 1? It's being added by b sub 2, multiplied by h, and divided by 2. So first thing I'm going to do is get rid of this fraction. So I'm going to times everything by 2. 2a equals h times b1 plus b2. Now I'm going to divide both sides by h, so I get 2a over h equals b1 plus b2. And if I'm solving for b1, I'm just going to subtract b2. So I get 2a over h minus b sub 2, and that's equal to b1. All right, so why did I do that? Because if they gave me the area, base 2, and the height, I can quickly find b1 anyways. Good enough? Cool. So let's look at the next thing, the last thing we're going to talk about. The last thing we're going to talk about is absolute values. So I have a 3-step process. First thing, you want to get, you want to isolate the absolute value. So solve to get the absolute value by itself. And then you make 2 cases, and this is the most important. Solve and check. Because sometimes it does not work. So sometimes it does not work. So first thing, let's isolate the absolute value. Did we isolate it? We sure did. So now I'm going to split into cases. Negative 2 minus 10w equals 98. And negative 2 minus 10w equals positive 98. So then I'm just doing this like we did before. We're adding 2. We get negative 10w equals 100. And then we divide by negative 10. So w equals negative 10. And let's add 2 here, add 2 here. We get negative 10w equals 100. Oh, no, we don't. We get negative 10w equals negative 96. And w equals 96 over 10. All right, so we say check. You can plug these in if you want. So if you plug it in, you get the absolute value of negative 2 minus 10 times negative 10 is that 98. So negative 2, so negative 2 minus negative 2 plus 100, this gives me 98. And what's the absolute value of 98? 98. Let's try the other one. We got 96 over 10. So negative 2 minus 10 times 96 over 10, that's supposed to be 98. So negative 2 minus 96, negative 2, that's negative 98. And what's the absolute value of negative 98? 98. So that one works. So that's the 3-step process, okay? Look at this one. What do we want to do first? We want to divide by negative 4. So that's 9. Now split it up. 7 minus a equals 9. And 7 minus a equals negative 9. Subtract 7, subtract 7. Negative a equals 2, so a is negative 2. This guy, subtract 7, subtract 7. Negative a equals negative 16, so a is positive 16. Check your work. Does negative 4 times the absolute value of 7 minus a minus 2 equal negative 36? So 7 minus a minus 2 is 7 plus 2, so this is 9. So negative 4 times 9 is in fact negative 36. It works. Let's do the same thing for 16. Negative 4, 7 minus 16, is that equal to negative 36? 7 minus 16 is negative 9. The absolute value of negative 9 is 9. So it works. These two check out. That's awesome. Okay. I got a couple more. So this one, first thing I want to do is subtract 1. Negative 30, and then divide by negative 10. Split this up. So subtract 3, 9r equals 0. So r is 0. Subtract 3, 9r equals negative 6. R is equal to negative 6 over 9, also known as negative 2/3. Check your work. Plug in 0 up here. So 1 minus 30 is negative 29. So that first one checks. Plug in the other one. 1 minus 10. And then r times negative 2/3 plus 3. Is this negative 29? So 1 minus 10 times the absolute value, that's a 3, that's a 1, negative 6 plus 3. Negative 6 plus 3, I believe, is negative 3. 1 minus 30 is, in fact, negative 29. That checks out. So it's important to check them because sometimes you get extraneous. All right, first thing we're going to do here, we're going to add 5. Split up into 2 cases. And here's the other one, 6n minus 7 equals negative 3n plus 5. So then this guy right here, you're going to subtract 3n, right? So you get 3n minus 7 equals 5, add 7, 3n equals 12, so n is 4. This one, you distribute that negative through. So I'm going to add 3n, so I get 9n minus 7 equals negative 5, add 7, 9n equals 2, n equals 2/9. Okay, we need to go back and we need to check. So let's check it. So our original problem was the absolute value of 6n minus 7 minus 5 is supposed to be 3n. So let's plug in 4. 6 times 4 minus 7 minus 5, and that's 12. So let's see, 6 times 4 is 24, 24 minus 7, that's 5. What's 24 minus 7?